Hi everybody, let's continue our telecom series. So today's syllabus is digital modulation criteria for scheme for using digital type of modulation. Then we will discuss about ASK scheme, FSK and BPSK. So moving ahead, these are the parameters which are required. So based on these parameters, we will get to know what kind of digital scheme that we can use. So starting with the bandwidth efficiency, the efficiency of the bandwidth utilization is measured in bits per second per hertz. One parameter is power efficiency, which is energy per noise PSD, that is energy per bit divided by noise PSD. PSD is for power spectral density. Then we have very common and very important theorem, that is called Shannon theorem for maximum capacity which the line carries is measured in C equal to B, that is bandwidth, log 2 1 plus SNR, that is signal to noise ratio. C stands for the capacity bits per second, B is the bandwidth in hertz. Then we have pulse shaping, which reduces ISI, inter-symbol interference. Then we have differential coding and non-coherent detection, which simplifies RX design. We have limited max phase shift, which reduces power consumption, improves performance in multipath fading condition. Then we have trade-off depending on the requirements. So these are the parameters which are required to identify what is the criteria for digital modulation and which scheme we have to use for particular communication. So we have already discussed the criteria for choice of scheme. We have discussed about the maximum data rate, channel bandwidth, minimum transmitted power, low BR, low interference, less circuit complexity, less power consumption and good performance in multipath fading. So these are the important criteria for digital communication and digital modulation. So here we will see ASK, amplitude shift keying or on off keying. So in this we have baseband signal, which is just generally information of signal that we want to carry, and the carrier signal through which we will superimpose our baseband signal, and now the final result we will see modulated carrier. So in that we have seen that baseband signal is modulating carrier signal. On the basis of that we are getting the result for modulated carrier signal. So when there is a 1, there is a amplitude 1, and for that there is a output in modulated carrier. For 0 there is no output at the modulated circuit. So in this way ASK, amplitude shift keying, works. So now let's discuss about the FSK, which is frequency shift keying. In that the carrier frequency is changes with respect to the baseband signal, and here we see that when the signal which is baseband is 1, wherever it is 1, the frequency at modulated output is very high. You can see that F1, and for 0 signal the carrier modulated, and we will get this as a F0 and very low frequency. You can see this BFSK modulated signal too. Basic funda is that in case of ASK, the modulated signal is modulated on the basis of amplitude 1 and 0, and in the same BFSK the modulated signal is when there is a frequency change F1 and no frequency change F0 in the output. A mathematical representation of F1 F0 is like A cos omega C plus del omega T. The basic idea for the digital communication ASK and FSK. We will further discuss these things in detail in the next videos.